Hi guys, I'm Arif and I'm going to define permittivity. This is my second presentation. My first presentation was about charge. You can find that presentation on YouTube. What is permittivity? What is its actual meaning? A lot of students they don't know. There are many students that don't know the actual concept of permittivity. There are many people they say that permittivity is just a constant, a convergent constant between the two systems, SI system and Gaussian system, unit systems. But here I'm going to define permittivity in a different way, with a different concept. Permittivity is a measure of the amount electric flux that is generated or permitted between opposite charge in a medium. This value is dependent upon the amount of polarization of the dipole in the dielectric medium. Dielectric medium means a medium. When you place that medium between the two charges, the one side of that medium become positive and the other side become negative. This is called dielectric medium. Hence, like in classical mechanics, we have a term inertia. Means everything want to maintain its nature, get its state. Like we, according to first law of Newton, that a body would be at rest, would try to be at rest, would be at rest or in uniform motion with uniform velocity if the external force is zero, if there is no external disturbance or perturbation. Hence, similarly, and everything want to maintain its position and everything resists the external perturbations and forces. Similarly, atoms, they are also tiny bodies, also want to have its original shape and position. We already know what is the shape and what is the configuration of electrons in an atoms, and where is proton, where is neutron. Atom is naturally, it is a neutral body, but if you would apply or exert any disturbance from the outside, the medium would start to resist that disturbance and would try to maintain its original position and state. Because the atom want to have its original position, original state that nature gifted it. Permittivity relates to the material ability to transmit or permit an electric field. We can see here that the first of all, when there is no perturbation, no external force, the atom is unpolarized. But when we place that atom between the two charges, external charges, there is one negative charges, the other is positive charges, the atom become polarized. The other one side become partial negative and the other one partial positive. This is the phenomena of one atom, but In a medium there are many atoms, and if you would place that medium between two charges, like in capacitor, here there is a capacitor, positive charge plate and the negative charge plate. When we place a medium between these two charge plates, there are lot of atoms inside that medium, and all the atoms become polarized, and we can see, and why these all atoms become polarized. It's polarized to cancel out, to decrease that external effect, external perturbation. And here that external perturbation is the external electric field, and the atoms polarized in a such a way to produce inside an electric field, which is called induced electric field, to neutralize, to resist that external field. We can see here that here inside the medium, the positive charges are here. These positive charges and negative charges are here. All the internal charges will be cancelled out with each other, but the external field, there is negative charge. There are negative charges and there are positive charges, and always the electric field direct positive to negative, and the external electric field is directed from positive to negative upward in this direction. But inside the medium, the induced electric field, that is directed opposite to that external field. Here are positive charges and here negative charges. The internal induced electric field will be directed in this direction, inward, downward, and the external field is upward. Hence the induced electric field offer resistance and try to weak the external electric field. You can say this is just like a inertia, just to stop that perturbation. But there is a question that if we placed a media dielectric between two charges, the atoms of that medium become polarized. But here we already know that vacuum has also a permittivity value. The vacuum also upper resistance to electric field. We know that vacuum is a empty space. There are no atoms, no particles. From where this resistance come to exist? So the answer is vacuum is not actually an empty space. It actually consists of equal number of particles and antiparticles. Like we say that if there are positive charges and negative charges, like an atom, we say that atom is a neutralized body. There are positive the number of positive charges equal to number of negative charges. Hence the total charge is 0. We said that there is no charge. Hence similarly in a vacuum, the number of particles equal to number of antiparticles. They would cancel each other and the number of particles would be 0. We say that there is no particle in vacuum. The total number of particles is 0. And due to polarization of these particles are antiparticles with small displacement, vacuum offer resistance to electric field lines. I think it will be clear to you. Now, relative permittivity. Relative permittivity tells us that how much times the permittivity of medium is greater than vacuum permittivity. We know that what is the vacuum permittivity. Now there are other media, and the relative permittivity of a medium tell us that how much the permittivity and the resistance of this medium to an external electric field is greater than the resistance of vacuum to electric field lines. So hence epsilon equal to relative permittivity multiplied by permittivity of vacuum. The force between two charges decreased by epsilon or relative permittivity when a medium is placed between the two charges than the force when there is a vacuum. Hence, when the two charges are placed in a vacuum, there would be a force of attraction or repulsion. We already said that vacuum offer very low resistance to electric field. There will be a greater force, greater value of force there will be. But if we placed any dielectric medium between those charges, due to polarization of that medium, the electric field value would be decreased and the electric force value would be decreased. And how much it would be decreased? By the value of epsilon or that medium. Hence in a medium the force decreased between the two charges by epsilon or, then the force is compared to the force of vacuum. Hence epsilon r equal to, from here we can derive epsilon r equal to, here from here we can derive this epsilon r equal to f vacuum divided by f medium. So how do you know the value of epsilon or relativity of a medium? Their formula: place two charges first of all in a vacuum and calculate the value of force F vacuum. Then place those charges in a medium. The medium, you want to know the relative permittivity of that medium, and then find the force value if medium, and according to the above formula divide F vacuum divide by F vacuum by F medium, and we will get the value of epsilon or relative permittivity of that medium. Relative permittivity is a dimensionless quantity. And why is it dimensionless? Because it is the ratio of two same quantities, F divided by F. This is also, these are the two same quantities. It has also a dimension Newton. It has also a dimension of Newton. Newton divided by Newton equal to 1. Therefore it's dimensionless. There are a lot of materials. They have different dielectric constant. Epsilon are also called dielectric constant. Barium titanate, it has value 1200. So greater value, very high value, greater value. In water, sea water, its value is 18. In water, distilled water, it's 81. Sea water has less value. You know that there are many salts in sea water, therefore its permittivity becomes less than distilled water. Nylon, paper, we already know that that's in air, that is 1, and here the vacuum permittivity does not exist, but you know, we already know what is the vacuum permittivity. The permittivity of air and vacuum is approximately same. Vacuum permittivity is approximately same, but here in the table we can see that the water has very greater value. What is water? Permittivity is a very greater value. Hence the dielectric constant or relative permittivity of water, it has very greater value than the other. Therefore water is a universal constant, and other than unpolarized materials, all the material, salt in water, we can take example of NaCl. NaCl, sodium has a positive charge and chlorine has a negative charge. There is a electrostatic force between sodium and chlorine, but when we drop amount of salt, table salt, to water, water, we know that water has a very greater value of dielectric constant, or its permittivity, water permittivity or resistance to electric field lines 81 times greater than the value or resistance of vacuum. Actual mean. Hence, water offers very high resistance to the electric force between sodium and chlorine, and due to this resistance, the force between sodium and chlorine become weak, and sodium and chlorine dissociate in water. Similarly, if we want to dissolve any other things in water in place, hence the dissociation of something in a solvent, this dissolving power of a solvent depend upon the relative or dielectric constant of that medium, but it is just for ionic compounds, polarized compounds. Thanks to all. If you have any question, you can contact me through my email address, and please visit us on Facebook, www.facebook.com/science. Thanks to all.